Welcome to 7.3. 7.3 starts logarithmic functions, which for a lot of students, this will be something that is completely new, was not covered in any of your previous math classes, and that's okay. So in the guided notes, they kind of go over logarithmic functions a little bit. I'm going to start with sort of different than they do. I want to just get a handle on what logarithms are before we talk about graphing and all that sort of stuff. So the logarithmic function base A is defined to be what? This. Y equals log base A of x means a to the y equals x provided a is non-negative. So first I want to underline here the word function. What I mean by underlining is I really want to enforce the idea this log is a function. It looks strange. I've got a word here, but sometimes what students will do will be like, oh, it's next to the x, so they're multiplying. They are not multiplying. Log is the name of my machine. X is the thing that's going inside my machine. And I actually have this modifier on my machine name. This is log base A, meaning I have different machines. They all kind of do the same thing, but one of them works with the number 2, another one works for numbers 4, another one would work with, the number 1 over 16. So they all kind of do something a little bit different. So that's what my base A here is. And if I have y equals log base A of x, that means that a to the y equals x. So a to the y equals x. So what's happening? What's happening here? Log base A of x has a parameter a, and in terms of an exponential, that a is a thing that we raise to a power. It takes in an x, okay? That x is the thing that comes out once I evaluate something to a power. And my logarithm spits out y, and in the exponential, y is the power. So it feels weird, but logs are really just a strange way to encode information about exponents. The exponent y and log little a parenthesis x parenthesis are the same thing. So this is an exponent just like the y is an exponent. Okay, so that feels weird, and that's fine. You can feel uncomfortable about it. I have a set of examples that I want to do just so we can kind of get more comfortable with logarithms. So first, let's rewrite logs as an exponential. I don't know if they make you do this in the Hawks at all, but I think that it's a good thing to do. So I'm going to start with a logarithm, and I want to rewrite it as an exponential expression. All right, so the first is 4 equals log base 2 of 16. So what that means is I'm working with the logarithm machine, specifically the one that works with 2. And into it, I'm going to plug the number 16. Out comes 4. So as an exponential, so the base here is the same base of my exponential. So the little number is what I raise to a power. What comes out of my logarithm is the exponent, and what goes in my logarithm is what that expression is equal to. So that means 2 to the 4th equals 16. So I can either write the number 4, or I can write log base 2 of 16. And when I see this log base 2 of 16, I'm thinking 2 to what power is 16? That's what the logarithm is trying to tell me. It's trying to tell me that it's 4. All right, let's do another one. So 3 equals log base 5 of 125. All right, so the thing I raise to a power is the little number. So here it's 5. Logs spit out exponents, and logarithms take in powers of their base, so 125. So 5 cubed is 125. I can either write the number 3, or I could write log base 5 of 125. Same thing. All right, here's a different one. Negative 2 equals log base 4 of 1 over 16. So if I see just this, I think, oh, 4 to what power is 1 over 16? Negative 2, right? Because 4 squared is 16, and then the negative makes a reciprocal. So the base is what I raise to a power, logarithm spits out a power, and the argument of my log is what that's equal to. All right, so I can either write negative 2, or I could write log base 4 of 1 over 16. All right, now let's go the other way. Let's rewrite a exponential expression as a log expression. So 3 cubed is 27. So log, what am I raising to a power? 3. What's the power of 3? It's 27. So this is a perfect power of 3. What power did I have to raise 3 to? 3. So 3 cubed equals 27. All right. Now I'm doing 4 to the 0 is 1. So what am I raising to a power? The number 4. So I'm working with the log base 4 machine. What goes into my machine is a perfect power of the number 4. So in this case, the number 1. What power do I have to raise 4 to get 1? 0. So 4 to the 0th power is 1. All right, last one. So I've done ones up to this point that you could have done yourself. You don't need a calculator for. This one I did by calculating with a calculator. 6 to the 2.1 is 43.06. So what do I raise to a power? 6. What goes in is a power, 6 raised to some power, which in this case is 43.06. What comes out is the exponent I needed. So 6 to the 2.1 is 43.06. So logarithms can take in positive things, and they're going to spit out both positive and negative things. All right? Think about it in terms of your exponential. This exponential, a to the y equals x, so y could be anything, positive or negative, which means this y is positive or negative. X would have to be only positive, because if you raise a positive number to a positive power, raise a positive number to any power, it's only positive. So that means my logarithm's only going to take in something positive. All right. Logarithms are just different ways to write numbers. They're different ways to encode information about exponents. If I want to raise 3 to a power and get 27, I need the third power. If I want to raise 0 to a power to get 1, if I need to raise 4 to a power to get 1, I use 0. If I want to raise 6 to a power to get 43, I need 2.1. All right, so I don't think that they make you do this problem type in Hawks, but I think that it's good to do these. So another type that I'm pretty sure they do make you do is some exact values of logarithms. So let's do some find the exact value. When I see this, if it helps, go ahead, write equals x, and then write it as an exponential. 4 to what power is 64? 4 to what power is 64? Well, let's see, 4 squared is 16. 16 times 16 15 is 64. So if I take 4 to the 4th power, that's 64. So my answer must be 4. 4 to what power is 64? 4 to what power is 64? So when I see this, I ask 9. To what power is 9? Well, the first power, right? If I raise 9 to the first power, I get 9 out. If you like rewriting it as an exponential, 9 to what power equals 9, of course, the first power. All right. Here's log base 4 of 2. Log base 4 of 2. So this thing, this number, I shouldn't even say thing, it is a number. This number, whatever it is the number that the power I need to raise 4 to in order to get 2. So 4 to what power is 2? This one's kind of hard. Four to what power is 2? Well, how would I turn a 4 into a 2? I could divide by 2. True, I can do that. I don't know how to write divide by 2 like as a power though. Like there's no way to rewrite that as a power. I can take a square root. So the square root of 4 is 2. And square roots are actually powers. Now I had mentioned that back in the very beginning of the class, I think, when we were doing exponent rules, and I couldn't remember if they did it in Hawks or not, but I said it was going to come up again. Here's where it comes up again. If I want to take a square root, I can rewrite it as a fractional power. So 4 to what power is 2? The answer would be 1/2 power. All right, log base 3 of 1. 3 to what power is 1? 3 to what power is 1? Well, anything except 0 to the 0th power gives me 1. So this one must be 0. Now the thing that's uncomfortable about logs is they have a word in them, log, and they're somehow supposed to represent numbers, and they do. The number that I raise 9 to get 9. 1. That's what log base 9 of 9 says. It says whatever I am, whatever number I am, if you make me an exponent on a 9, you get 9 out. Okay, so I must be equal to 1. All right, if you feel still a little shaky on logarithms and feeling comfortable with them, do more of these types. And if you want me to direct you to some, I can. Just send me an email or a Blackboard message. I'll direct you guys to some more. But think about writing exponential stuff. So you guys can write exponential expressions hopefully all day long. You just punch them in your calculator, right? So 5 to the 6 is 15,625. So write that thing as a logarithm to get more comfortable with logarithms. Logarithms are going to be able to take in anything positive And they're going to be able to spit out both positive and negative things because the powers of an exponential could be positive or negative. Now, because of this relationship, so in goes x, out comes y for the log, but for the exponential, in goes y, out comes x. Because of this relationship, the logarithm and the exponential are inverses, and that means we know something about the domain, the range, and their graphs.